So looking at the same thing we just looked at, which is that. Come on. Here we're looking at it in a slightly different way, but very much from the perspective of natural selection. So we have this potential for an allele to be come into the population by mutation or migration. So that's the origin of the allele within the population. It can increase in frequency to the point of it being a polymorphism, to the point of it being predominant within the population, and even to the point of where it can be fixed within the population. And when you have a steady march of an allele upward like this, it's usually a sign that we have natural selection going on. And why is this? It's because whatever this allele that we're looking at is, this beneficial allele, it's increasing the potential for survival. It's increasing the reproductive success of the individuals involved. And as a consequence, those individuals are leaving more progeny. And so as time goes on, you have this steady march of an increase in the frequency of that allele that's giving rise to this greater reproductive success until perhaps it reaches the point where it goes to fixation. You can also have that kind of marching up with genetic drift, but you tend not to, because genetic drift is a random process. Genetic drift might give rise to fixation of allele, but it'll do so with the allele frequencies bouncing all over the place. And they might bounce to the point where they cross that line or reach that line, in which case they've given rise to the extinction of the other allele, or they in fact might reach the point where they've hit that line, at which point you've lost the new allele. But the randomness, I mean, this would be a random process, marching through time. It's all over the place. Whereas with natural selection, you get this very deterministic marching of the allele up from its origin through to its fixation within the population.